Okay, Mr. Smith here. We're in Algebra 2, Section 6.3, and we're working with function operations, but specifically we want to focus on composition of functions. Okay, so you know four main operations: addition, subtraction, multiplication, division. We could call exponents another operation. We know how to work with exponents. That's another operation between two numbers. But I'm going to introduce to you today a new operation. It's called function composition. It's a new operation. You've never seen this before. And in general in mathematics, we don't have that many operations. We can do some very interesting things with them. But the number of operations we actually have are quite limited. Okay? But before we get to composition, we're going to do a brief review of addition, subtraction, multiplication, and division. And I'll tell you, it works exactly like you would expect. If I want to add two functions, I take the two functions and I add their like terms, right? So here, 5x plus x plus 2, well, just 6x plus 2. Right? And it works like you'd expect, and we've actually seen this throughout our time together. Okay, so these are our basic four operations. Everything we're going to work on generally today is going to look like a power function. This isn't a big deal. All right, so here we are. So they define f to be 3x to the 1/2. So it's the square root of x, right? And they define g to be negative 5x to the 1/2. Just a clarification on the notation. 3 is not being square rooted here. It's the x. So we see that. And so they want us to add the two. So f plus g. It's going to be 3x to the 1/2 minus 5x to the 1/2, and this is just negative 2x to the 1/2. Okay, not a big deal. If we want to subtract f minus g, it's just going to change our sign in the middle. We get minus a negative 5x to the 1/2, and we get 8x to the 1/2. I think this is a very welcomed problem compared to what we've done. Now, part C asks about the domain of f plus g and f minus g. So when we talk about domain, what we mean is what values of x am I allowed to plug in. So here, if we look at f plus g, I get this new function, negative 2x to the 1/2, and I'm asking what values am I allowed to plug in for x. Now, it's probably worthwhile to think of this maybe as negative 2 times the square root of x. It might help us in our understanding. So for instance, can I plug in 1? Am I allowed to take the square root of 1? Am I allowed to take the square root of 0? In the real number system, yeah, square root of 0 is just 0. Am I allowed to take the square root of negative 1? Well, not in the real number system. In the real number system, we can't. But in the real number system, we can't. And so, for all purposes, we're talking about domain as reference to the real number system. And so we're not allowed to take a square root, or a 4th root, or a 6th root, or an 8th root, an even degreed root. We're not allowed to take negative numbers. We're not allowed to have negative numbers under there. So we say the domain for f plus g is going to be from, sorry, let me fix that a little, from 0 to infinity. Okay, the domain is from 0 to infinity. Any positive number and 0 I can plug in there. I can't plug in this number. And for any even root, you might put this in the margin, for any even root, this will be the domain from 0 to infinity. We're not allowed to have a negative number under an even degree root. Okay. You can also write this a different way. If you want to use a different notation, we can say x is a real number, x is any real number such that, let me actually use a colon here, such that x is greater than or equal to 0. those two statements mean the same thing, mathematically in general. So from here, the domain is from 0 to infinity, including 0. Here, x is a number such that x is greater than or equal to 0. And this will be true of any even degree. So minus g also has the same domain. It's 8 times the square root of 1/2. So f minus g will have the exact same domain. Okay. Let me show you two more examples here. So they want us to do f times g. All right, so they define f as 7x, f times g, and so this is 7x times x to the 1/6. So I'm going to write this as the 6th root of x, just so we see it here. And try to combine these, but you don't really. Right? In fact, I would say this is a more simplified form. And that we get x to the power, just like this. And the same thing goes for f divided by g. Right? We get 7x over the 6th root of x. Now, technically, we're supposed to rationalize the denominator here because we're never going to have a square root in the bottom. We're not allowed to have any roots in the bottom. I want to talk about the domain. So, for f times g, I have an even root. So, basically, I can plug in any positive number. The fact that this piece is for the 7x piece, this is the only one that does anything to the domain. And it basically says the domain, again, has to be from 0 to infinity. I can plug in 0. I'm allowed to plug 175, 97. I'm allowed to plug in -3. I can put a -3 here, but I'm not allowed to have a -3 there, and therefore the domain is from 0 to infinity. Now the second example, f divided by g, it's a little different. Again, we have a 6th root. So I know that the domain should be right. The domain of f divided by g is almost this. So why not? Anyone see that? If you're watching at home, you can join in. Obviously, we can't put in negative numbers. That's not a big deal. I can't put in negative numbers because I have this 6th root here. There's one other piece that stops me from using this domain. Go ahead. It does. One of the students said that it has to do with 0. I'm going to take that farther. Wait. That is not true. Now, if you put in 100, you're not going to get 0. Okay. All right. Go ahead. You're not allowed to divide by 0. So the 6th root of 0 is 0, but we have this rule that you can never have 0 on the bottom of a fraction, which means the domain can't include 0. So this is wrong, although it's very close. The domain instead is 0 to infinity, but notice I don't use a square bracket. I use a rounded bracket. And the rounded bracket says 0 is not included. 0 is not included. We're never allowed to have a 0 on the bottom of a fraction, and therefore it's not part of the domain. Very good. Okay. Otherwise, I feel like generally for most of you this is nicer than Section 6.2. And so here's a problem. But this time I want to press on. And so if you're working at home or you want to do this at home, so I'd be happy to help you through if you had any questions. But again, what you're going to see is we're taking x to the 3/2 power. So that is an even root. Again, if I have 5x to the 3/2, this is basically like taking a square root. The denominator tells us what root we're taking. So the domain here would be generally from 0 to infinity. If it's an odd root, it should be all real numbers as long as we're not dividing by 0. Okay. So let's build on now, and this is the main emphasis, the new part of the section, and this is about composition of functions. The idea of a composition, and we're not going to do it this way, but the idea is that I have some input, and I take it into function f. And I take that input, and I get some output. Okay. And now I use that output, whatever that output is, and I use that as the input to this new function g, and I plug it into g, and I get some output in g. Okay. So again, I'm going to take get out an output. And now I take that new output, and I use that as the input for my second function, and I get out the final output, and that's the answer we're interested in. Okay, so it's basically like using two functions together. There are several examples in the real world where we want to do this. Okay, and this defines a new operation called this function composition, and we don't do it number by number. Okay, so it's not like we're going to take and do for every number, we're going to plug it in like this, but it helps to define what we mean when we say composition. So here we're going to define f of x is 6x to the negative first, and we're going to define g of x is 3x plus 5. And the first function they want us to make is called f of g of x. F of g of x. So what we do is we take function f and we write it out. 6x to the negative first. Where there's an x in function f, we replace it. So everywhere there's an x in function f, we're going to replace it with function g. And that is the idea of a composition. And I'm going to go back. I want you to see the composition process a little bit more. So for the next one, they give us g of f of x. G of x. Okay. And so what we do is we write out function g, 3x plus 5. Everywhere there's an x in function g, I'm going to replace it now with the other function in function f. So we'll erase this out. And here we get 6x to negative first. Okay. Let me show it to you one more time. I'll pause for questions, and then I'll go back and I'll simplify it again. All right, so the last one is f of x. Okay. So I write out function f, which is 6x to the negative first. And now everywhere there's an x, I'm going to erase it. Everywhere there's an x, I erase it, and I'm going to replace it with function f. So actually be the same thing here. So we'll put in some parentheses. We get 6x to the negative first. And that is the idea. So we write out the first function. We write out the first function, and everywhere an x, I replace it with whatever's inside here. Okay, so they tell me what to replace it with. And that creates a new function. And the idea of function composition is we are going to take two functions, we're going to use them to create a new one. And that's it. Okay. So are there any questions? I want to talk about the domain. So here, notice that everything in the is being taken to the negative first power. Everything in the parentheses is being taken to the negative first power. So basically, that's going to shift to the bottom of the so the 6 is not being taken to the negative first, just the parentheses. So the 6 stays in the top, and the 3x plus 5 goes to the bottom. And that's the new function. That's the create a new function, and we have created. Notice that the first only applies to the x. Negative first, the negative 1 power only applies to the x. So the 3 and the 6 we can multiply. 3 and the 6 we multiply gives us 18. The x to the negative first puts it in the denominator. Now there's a plus 5 at the end. That's the second function. The plus 5 is a new term. So, I mean, if you want to think of it, it is 5 over 1, but I can't write that all as one fraction unless I had a common denominator, like a common denominator x. Okay, so kind of imagine this were like 18x plus 5. Right? Well, you're not going to bring the 18x and the 5 together because they're not like terms. Similar here? Does that help? Okay. And this last, let me do the last one. So the orange negative 1 applies to the entire parenthesis here. Right? The orange negative parenthesis, so it's going to shift everything here to the bottom of the fraction. It's going to be 6, that's the orange 6 here, and then divided by 6x to the negative first. Okay, so the entire blue set of parentheses went to the denominator, the orange 6 stayed in the numerator, and now 6 divided by 6 is just 1, x to the negative first comes up to the numerator, and so we're left with just okay, 6 divided by 6 is 1, x to the negative first power. And the denominator shifts up to the numerator. So if you want to write this as x over 1, you could, but we don't do that. We just say x. We assume that it's over 1. Okay. So let me pause there for just a moment. Okay. So the last thing we need to do is talk about the domain of each function. And I'll try to squeeze that in black so we can see it. So let's start with the last function, f of x. And it's just y equals x. So what numbers am I allowed to plug in here? Or conversely, what numbers am I not allowed to plug in there? The answer is I can plug in everything. Right? I can plug in any real number and I'll get out a real number. So the domain here is from negative infinity to infinity. It's all real numbers. Or you could write out all real numbers. The domain is all real numbers. So the third example, I can plug in any number. Okay. On the second example, there's one number that I'm not allowed to plug in, and that is 0. I'm not allowed to have x be 0, because then I would get 18 divided by 0, and that's undefined. So, for the second one, the domain is from negative infinity to 0, but not including 0. Or from 0, but not including 0, to infinity. That's one way to write it. Or an easier way to think about it is x is evaluated in the real number system such that x is not equal to 0. Either one of those ways means the same thing. On the last one, there's one value of x that I can't have again, but it's not 0, because 3 times 0 plus 5 is 5. I'm allowed to have 5 in the denominator. So what I need to figure out is that there's some number 3x plus 5 that equals 0. And so if I solve this, x would have to equal negative 5/3. So this is the value that x is not allowed to be in the bottom of the fraction, because that's the value that will make the denominator 0. And that's the key. The denominator cannot be 0, which means the denominator cannot equal negative 5/3. And so again, x is evaluated in the real number system, but x cannot equal negative 5/3. All right, thanks for your attention. This concludes section